Hello everyone, and welcome to our regular core protocol sync. We will share updates on the core protocol, a little bit of research from last week, and immediate plans for the future. And as usual, Shamil, do you want to kick us off?
Sure. A moment. I will share my screen. So last couple of weeks, I made multiple changes to support our testnet. I made several improvements to adjust local caches on the node side and on the farmer side. There are several pairs for that. It's basically changes the ability to maintain caches both on node side that produce pieces and on the farmer side that contain pieces caches and also archival storage cache. So those changes increases our local caches to some predefined size. We currently chose 1 gigabyte for each application, and also there are several arguments to adjust those parameters. Also, there was a task for basically it's a tech debt to restore our DSN block importing proof of concept. It allows the node application to sync blocks from the DSN. There is a special comment on that. I restored the code, and Nazar later adjusted it more, and it actually works now. Nazar will tell about probably more. Also, I added multiple improvements for the DSN to clean addresses, stale addresses from the Academia network structures, internal structures. For example, this PR will prevent non-public, non-global addresses from the Academia internal structures. What it means that we prevent multiple addresses that peers advertise to poison different memory structures in Academia. It will reduce incorrect requests by probably 60% if we compare to the average advertised addresses for each node. Also, there was a similar bunch of PRs. For example, this PR introduces persistent network identity for the farmer. It derives that network identity from the disfarm identity. So on restart, farmer maintains the same network identity. What it means that it will have the same peer ID on the multiple restarts, and it will also reduce incorrect requests. The next, also reducing incorrect request PR, was handling wrong peer error, connection error for libp2p. This small change for the code basically handles this particular error, Academia error, and it will remove that peer ID along with all these incorrect addresses from internal structures. All those PRs handle some kind of particular error that we encountered during our tests. These couple of PRs, this piece receiving butcher and piece publishing butcher, it's an improvement for farmer. It allows to make those requests for the DSN in controllable batch. There is a CLI argument for each batch size. It is adjustable argument. What it does, it allows simultaneously requests multiple pieces from the DSN. It's controlled by this semaphore from the Tokyo crate, and it's also adjustable. This mechanism is batching was implemented for piece receiving and piece publishing mechanism. What I am doing currently at this week, I will finish the similar mechanism for Node, which is piece publishing from the node side. And after that, I will move to the to that issue that we are now able to solve, which is Kademlia pool model. I started this work last week. I started to migrate the LibP2P version, and I was blocked by the incorrect LibP2P release. But Nazar took over, and he created some more features like streaming, and he will tell about that in his presentation. That's it.
That was a lot of updates. Anyone has questions about anything Shamil just said? All right, let me share my screen then. Should be this one. I'm sorry, looks like my browser just crashed. Let me try again, if I can. It's a different computer this time. Okay, it doesn't seem to be cooperating, so I'll be sharing links to you guys and you can follow from there, if that works. So the first pull request was about updating the way we are building runtimes. So essentially what we had before, we had a special case comparing to most of the substrate chains where we are having one runtime within the other runtime. And what that means is that in each runtime, we have a build RS file, which is doing the WASM compilation. And that was running even if there is a WASM runtime that depends on WASM runtime. In which case, we're just like including sources. We don't really need WASM blob, but it was still building. And that was actually occupying quite a bit of CI time. It was occupying some disk space. And in our case, it was actually even worse because after substrate upgrade, there were some components in dependencies of that build script, which were especially heavy. WASM opt crate specifically, that is like completely unnecessary. So this pull request is quite simple. It basically disables building of that WASM under if unless the STD feature is enabled. So if STD feature is enabled, we need to build WASM blob. Otherwise, we don't care about it, so we can skip it. And a similar pull request is actually submitted upstream in Substrate, but that is most like an example for other projects to follow. It works correctly either way, just wastes time basically. Then there was a small pull request about updating the Blake 2 library. Essentially, there were two libraries in our dependency tree. One of them was more like the better version to use, and the other one was that we were using. And the reason for that was that there was some API misunderstanding. And I have submitted an issue in Substrate for them to basically converge to one library across the stack. And once we pull the Substrate, we can actually do the same. So the whole stack we have uses the same exact library. So we have less code to compile, we have less smaller WASM blob size and so on. So that is a good thing. Then there was a small pull request that was changing the way we are doing CI. Essentially, we were running CI on every commit and then on every pull request. We discussed that it is kind of heavy for us. We do not have many workers, especially for macOS. So we can run just for pull requests. And if you want to run something for commit, you can actually go and dispatch a workflow manually in GitHub Actions. So that should be sufficient for most things. So that's how we save a little bit of time. And there is another pull request I will share later about some more improvements to that. Then there was this one about fixing the DSN sync for Node. Essentially, it never worked because we never really had any meaningful DSN to work with. The reason for that was that we were basically what we're doing here. We are kind of repurposing the code from Substrate, where they have an ability to export block to a file or like series of blocks and then import them back, right? We are doing essentially the same. However, we are taking blocks not from file, but from DSN. We are reading the history start to finish, and we are reconstructing all of the blocks we have been archiving, and then we are importing those blocks back into the chain, and we arrive at the same state as we would have if we were syncing from the network. So all that is great. And in order to achieve that, we are essentially instantiating part of the client, not the whole client. We don't need networking, we don't need some other things, but we do instantiate a part of it. And the part we were missing the archiver. So archiver didn't produce root blocks, and when we were actually trying to import blocks, they were not verifying as soon as we hit the archiving point, because root blocks were missing in the client generally. So that was the first part, and then there was one part missing that didn't actually wait for all blocks to be imported. So even if we were to import blocks, we were not importing all of them, at least not all of them that are available in the DSN. So with those few updates, it does actually work. So you can technically run this special command on the node. You can import blocks that are archived in the DSN, and then you can restart node in regular mode, and it will continue from there. Assuming that you were actually syncing on the correct chain, which is not currently verified, but this is like a social consensus. You can just check the latest block you have, and you can verify against Block Explorer or a friend or whatever to verify that you are on the correct chain that you think you are on. So that is kind of a stepping stone to actually sync the full node properly from DSN. This is like a proof of concept, and we can actually extend that probably later, where node can switch between these two modes during startup. So we can like create a DSN instance, we can pull blocks, we can import them, and then we can start the proper client, full client, and then we can continue from there. Essentially, the end goal here is to remove the notion or like the need for archival nodes from Substrate point of view, and just have DSN for everything, right? Then there was an interesting challenge once we started to actually test everything, and it turned out that the node actually doesn't sync, which in practice wasn't actually the case. It was just that the publishing of pieces was extremely slow. Some of the challenges of that Shimil already fixed, but nevertheless, it was a problem. And the problem was that we were doing that from block import pipeline. So when we do archiving and we produce a segment, we are trying to publish 256 pieces one by one, and we are waiting for each one of them to finish before we start the next one. And that basically takes a very, very, very long time, like 10 seconds plus for one piece. And for the user, it appears that block import just doesn't work. Like it has everything in memory, it just cannot continue until it finishes block import for the previous block. So by moving all of those things into the background, which actually doesn't have to block the block import necessarily, we were able to sync the node much faster and without major problems. So that was an important change there. Then there was this pull request, which the farmer is basically not working with node for the block retrieval anymore. It does use DSN, so other nodes and farmers. However, it was waiting for piece retrieval for a very, very long time. And it also did one request to the cache first and was waiting until that fails. And then it was doing a request to the archival or like the caching layer on the nodes. And it was also waiting for a long time. So I have implemented a few timeouts there, and also I implemented some races where if we are not getting piece from the cache within some reasonable time frame, we are in parallel trying to get the same piece from the other kind of storage on the network. So ideally, we can get pieces faster regardless of where they are, right? And also added some retry policies that were missing, and some other improvements. So that essentially helped us not to only sync the node, but also to plot on the farmer, which is the crucial piece if you want to actually produce blocks. The next one, let me see. Yeah, basically, once we have all of that, it turned out that the farmer is actually quite slow in terms of the farming. It takes a very long time, and we are not trying to solve, or like we are trying to solve on every time slot regardless. So if the solving for one time slot takes more than time slot number of nanoseconds, then we are basically lagging behind infinitely. And that was not great. So this pull request basically made sure that we can skip some of the time slots if we were solving for too long for the previous time slots. We don't accumulate this like backlog basically. And we can actually move forward and not lag behind too far, because that causes a lot of different kinds of problems. And then interestingly, there is a pull request which is called fixed block production. By this point, you would have thought that everything is fixed, but it wasn't. And the reason for that was, let me see. Yeah, there was actually several. Yeah. Okay. So there was also piece publishing similar to the node on the farmer, and that was also slow. So that was also had to be moved into the background task. And then turned out that decoding for sectors was very slow. That's why it was lagging behind in the first place. And there was a different algorithm which is doing the same exact thing, the same result, but it is like 50 times faster on a single core. So that's something that Daria helped me with and was implemented here. And with all of those improvements in this pull request, you can actually run the node, sync it properly. You can start the farmer, plot the sectors, and actually produce blocks on the actual network. And from this point, when other engineers were trying to run it, they were actually finally successful. So that was like a big achievement last week. It was 5 days ago. Then there was an upgrade of lib peer-to-peer, as Shamil mentioned. We were seeing some interesting errors in some cases, and they were supposed to be already fixed. And we also had an issue with the pool model that we wanted to implement. We wanted to publish pieces not as values, but rather as a notion of providers in lib peer-to-peer. Basically, you are announcing that you have something, but you're not sending that something. You just send information about yourself, and when someone requests it, they will just get a list of peers that potentially have this data, and you can reach out to them instead. That was not working because of the bug in lib peer-to-peer. With this import, we are actually able to do that. One important change, though, and why this pull request is so big comparing to what it should have been otherwise, is that they have changed internal APIs on Connect side especially. Basically, they have this manually constructed state machine for the protocol, which is composed from different behaviors. And in particular, Kademlia behavior, it is emitting events. So when you start to request something, it will give you an ID, and then with that ID, you can capture the event later that corresponds to that ID with the results. Let's say you want to get some value, and you will get that value with the ID. What they have changed is they have implemented streaming, essentially, where for every of those IDs, you will have more than one event. So if you are discovering one peer that has the value and then the other peer that has a value, you will have all of those events. And then the very last event will say, I have nothing more. So that's like the end. And our API wasn't really ready for that. And we had to change a lot of things to actually return streams. So now when you want to publish something to DSN and you are saying, I want to publish for to 10 nodes on the network, it will give you 10 events in a stream, each corresponding to one peer it was published to, instead of having just a feature that resolves once everything is ready. So what this allows you to do, it allows you to follow the progress in the meantime, and it also allows you to drop the stream, and then it will be canceled on the other side on the networking layer if you don't care about the further results anymore. One interesting example for this is because we are not having content addressable values in the DSN, we can actually get a value which is not corresponding to the key, right? So you can actually query several nodes, and then you can drop the stream as soon as you get the first correct value, and you don't care about anymore. So that is something that had to change, and that had a bunch of implications. We had to invent some abstractions and some new patterns to keep the old semantic, but generally it works, and there is still a lot of opportunity for improvements with this API. but at least we have switched to this new version, and hopefully they will not make such drastic changes very often going forward. And yeah, the last one was an issue I was looking into for months. I think it was discovered in May the first time during Gemini 1. The basic problem, or like the way it's manifested, is that some nodes receive blocks which are not having correct contents, and they just reject them. However, some other nodes are producing those blocks, and in some special cases, they can even like go into the fork separate from the rest of the network, and they cannot converge back. And it was in most cases fixed just by restart of the node. In some cases, severe cases, it wasn't. So the reason for that is basically described in the pull request. You can look into it. There is a small diagram. The gist of it is that you might have forks. You may have two blocks at the same height. And when we are doing archiving, we are not archiving blocks at the tip. We are archiving blocks at specific depth. So when we have two blocks at the same height, we only need to archive it once, because at the minus k depth, there is just one block, which is canonical. And it might so happen that when we are archiving in one branch, the other branch just moves forward a little bit quicker, because the root blocks that we are producing, they are sent back over asynchronous channel, which doesn't have any time guarantees. And we might actually try to import the next block, which should have the root blocks, expected root blocks in the hash map, but they're not there. And in that case, you basically cannot verify it. And then you ignore that block and you basically go into the fork. And I didn't notice that asynchronous back communication channel before. So this pull request basically moves that hash map update into the archiving itself. And that way it is always consistent regardless of how many forks we are having imported in parallel. So that was very satisfying that this bug was finally fixed. And it will be part of the next snapshot. And there is just one more pull request to talk about, which is not merged yet, but I hope we will merge it today, which improves our CI a little bit more. It basically skips the tests on macOS completely, except for main branch. The assumption is that we have tests for Windows and Linux already, and we will still run Clippy. So we are still ensuring that macOS compiles. We just don't run tests. And since we don't have really a lot of platform-specific code, we assume that if tests for Windows and Linux pass and we can compile Mac, Mac will work as well. You can still issue the workflow dispatch manually, and you can test macOS if you want. It will be still tested on main, so sooner or later we will see that it fails. But we are just saving a little bit more time in CI for the pull requests. And the reason for skipping tests and not Clippy is that Clippy takes like 30 to 40 minutes to run, and tests take over 2 hours in many cases. So the idea is that we want to actually switch to beefier off-the-shelf workers in GitHub, but they only have workers for Windows and Linux. So we will switch those and we will run tests faster, and macOS will run the way it can, but only for Clippy. So we will not have to wait for macOS for 2 hours. We can actually merge pull requests faster. And with that sprint, these are all of the updates for last 2 weeks that I had. If you have any questions about any part of that, I'm happy to discuss. All right, silence. Rahul, why don't you update us on the progress of your onboarding so far? Maybe you have any questions?
Yeah, so I've been mostly reading all the technical documents, and I kind of focused on the different sharding schemes that we have under consideration in the Hitchhiker's Guide, like the ECP and semi-avid and so on. Now I'm waiting to sync with Jeremiah, so I know my next steps here. So that's mostly I've been doing. And while I was reading those things, I kind of made some notes on the side to help me understand what's going on. maybe I'll put the Notion page out so it may help others who are also trying to read that or something. So that is where I am right now. Apart from that, I watched the onboarding videos that Jeremiah gave to Parth, and those were quite helpful in understanding the overall picture, like relation between domains and the chains and so on. I still have some questions, but I plan to kind of go through them this week as I'm starting on other things. So that is mostly from my side.
Okay, that sounds like a good progress. Yeah, if you have Notion page, I think we can collectively try to answer all those questions, and we can probably improve some of our existing documentation going forward as well. Because it's a new look at what we have. We were working on this
Yeah,
for a long time.
I will try to clean that up and publish it maybe today or something. Main thing is, like, as I was reading the material, a lot of things are not very clearly explained in those papers. So I had to kind of spend some time to figure out how those things work. Those are the things I kind of put in the Notion page. So yeah, I'm hoping like that would also help others who are trying to read those stuff the first time.
Awesome. All right, Ivan, do you have any updates related to the core protocol or any requests or anything like that?
I guess no, apart from what we discussed like at the previous call related to the P2P. So yeah, nothing major.
I have a few questions to you actually. First of
Mhm.
all, do I understand correctly that we are still using RPC client, which is going through WebSockets between the node and farmer in the SDK?
Yeah, it is enabled, I believe. I mean, wait. Do you mean the RPC client? Like the rate which both which farmer has? Okay. I just mocked it. And like I don't actually use the WebSocket for the connection between
So
node
it
and
does
farmer.
direct connection between node and farmer.
Okay, can you repeat?
So it does direct connection between node and farmer within the process.
Yeah. Exactly.
Okay, that's excellent. But I think you still have two DSN instances, one in the node service, in the other in the farmer, right?
Yeah, it's because like I'm constructing the whole substrate node using the Subspace service like new full function, right? Which like collects all the components, right? And also creates the networking instance. So I basically can share the networking instance between those two. But yeah, but that would require like a lot of code import.
Yeah, I was looking into that. I think I will create a pull request which will expose tools for you to basically reuse the same DSN instance, because it's kind of wasteful to have two instances instead of one and expose two ports instead of one. Okay.
Great. Yeah. Actually, I have the one question related to the like not syncing. I mean, I tried like syncing today, like, and it actually seems that that for both like subspace node, which is binary for the monorepo, like I have the syncing status as idle always while I am actually importing box. Like, and I can see the target in the networking state even on the SDK, and I also get the networking state like idle while I'm actually syncing.
Yeah, in Substrate, it's kind of confusing the way it works. Basically, you have idle, you have downloading, and you have preparing. Downloading means that you are really far from the tip and you are pulling new blocks from other nodes. Preparing means that you have downloaded all the blocks you wanted, and you are relatively close to the tip, but the blocks you have downloaded, they are still in memory being imported, like they're in the queue. So that's preparing. That's what it means. And then if you are, I believe, within 5 blocks from the tip, regardless of whether you are at the tip or not, it will not show anything other than idle because you're like almost there, basically. Maybe with some of the changes we have done to the sync process, some of them got wrong, maybe. So I'll have to look into it. But generally, that's where you might have a confusion sometimes.
Okay then. I mean, just in case, like I implemented some sort of hack which just looks for the like whether the block was imported like within like last 3 seconds or 6 seconds, something like that. And if it wasn't, like I assume that the node is synced for now.
Well, make it like 30 seconds or a minute. That would be more appropriate.
But like, are we expected to have the block production at 6 seconds?
It is on average. Sometimes in real network, it does take like 20 seconds. It does happen occasionally. So just make it 1 minute. In most cases, it will not hit that anyway. And we will probably just fix it in our fork or wherever it happens.
Okay, I mean, how do you distinguish whether you're like syncing or you just on the tip at the tip of the chain?
Well, yeah, you have to also check the target. If you are at the target, then everything is fine. If you're not at the target, well, yeah, it gets tricky.
I mean, the issue right now is that like the substrate node doesn't have a target at all.
Then it must be at the tip.
No. It's like I'm at like block 10 or something, while we definitely have like 3K blocks or even more, like a card to an X-ray.
We don't necessarily have them at the nodes you are connected to. Like if a node thinks there is just 10 blocks, it will think that everything is fine. Well, we need to debug it basically.
Okay.
Perfect answer right now.
Okay, thanks anyway.
Hey, Nazar, I had one question for you. When you
Go ahead.
Hey, so you mentioned previously you had a PR to reduce the build times, right? I was wondering, like, we had like similar problems in the past, and we switched to Bazel for all the rest compilation. So are we considering anything like that, like migrating to Bazel for our builds?
I have not actually worked with Bazel. It would be a new build system, and we are trying to stick to like canonical Rust as much as possible. And in Substrate, they basically have some build scripts that they're like providing everyone to use that you can just add to your project, and you will enable like random compilation basically. I don't think it makes a lot of sense to rewrite that. And it does work fine if you have enough CPU cores. The problem in CI that we have just 2 cores, and you cannot do a lot with just 2 cores. So that's like the root problem. It wasn't the root problem that we were compiling extra stuff, but those extra stuff were slowing us down even further, and we just removed the necessary work at this point. Okay.
I have a question for Nazar as well. Sorry, Nazar, for interrupting. You mentioned that you are going to merge 2 networking instances for Node and the farmer, and I wonder, do you consider merging caches as well? Because the record store can have different semantics basically for Node and farmer.
Yeah. So
and
the way farmer works, we have farmer as library that exposes some data structures and some functions and stuff that you can use. And then we also have a binary which has some more stuff. It actually like orchestrates all of those components in a specific way. So the way those components are orchestrated in the SDK are different. For instance, E1 is not creating WebSocket RPC client because that doesn't require RPC client. It just needs some stream that has slot notifications, for instance. And that's why he can implement that in memory, just connecting Node and Farmer directly in the application. So the same way, he can decide which database implementation he wants to use for caches, whether he wants to have separate caches or the same caches. That's like up to SDK. We just need to expose a way to provide a custom networking instance, for instance, of the DSN into the substrate node, like the service that we have, Subspace service. Right now, it is created internally, so he cannot customize anything, but we just need to make sure he can.
It could require different custom implementation for record store then.
Yes, but we have a trait for that, so he can do that if need be.
Okay.
All right. Lu Chang, do you have anything you can share about the core protocol?
Yeah, I do have a few. Let me share my screen. Okay, so Yep, I have basically three peers corresponding to the co-protocol. The first one is actually a glitch like left during the code domain upgrade, and this one is like discovered by Ning. This is great. He has been like looking into the code deeply. Okay, the problem is that the palette domains of this primary chain like is expected to only check the system domain receipts, and we didn't do this like during the code domain upgrade. With this like condition, yeah, we are checking only the system domain receipts on the primary chain. The other like the code domain receipts will be tracked on the system domain, and specifically the palette domain registry, not the palette domains. This the digest of the job, and the second one. Okay, the second one is to basically it's an improvement to not have like a bunch of like confusing error logs. The problem is that when a new primary node like joins the network, it can like receive the transactions, which is like submit bundle transactions from the peers, but they cannot verify those peers because they haven't synced up to the tip. Hence, the receipts in the recent bundles, they are missing, like they cannot be verified because the current like node is still syncing, and he doesn't have the info of those like blocks that are like corresponding to the receipts in that bundle. So those like recent sign bundle on sign extensions will end up with those like error logs, and we simply decided to like have a kind of pre-validation in the transaction pool to detect this scenario, and if this bundle like have some like receipts points to a block which is unknown to current like nodes, we simply drop it like without calling into the runtime API. I think the core idea is and we already have this kind of pre-validation for the fault proof, and we extend this to a more general like pre-validation mechanism, and we added this like case variants for the receipts, and if this like extracting of the transaction is a submit bundle, and we can extract the receipts from this transaction and we validate, and if it has any like receipts points to a future block, we simply like we drop this unsigned extracting immediately without calling into the runtime BN. So we are free from those like confusing error messages in the log. Okay, the last one is pretty simple. It's a pure like refactoring to the proof election structure. Now, for the codomains, we just need the proof of the old proof of election to verify the bundle election. Like, but for codomains, apart from that, we also need some additional information to verify the codomain bundle like election, which is like the block info and the state roots when that codomain bundle solution was created. Those info are specific to the codomain bundle, so we have this like to support this, so that we not have this actually overriding. Yeah. So that's the PRs merged into the main branch. Oh yeah, also this one, I think there's a fix. There's a fix to the pre-dispatch for the submitted bundle experiencing. So the problem is that on the primary chain, or in the palette domains, we only track the receipt heads of the system domain. So we can only use these receipt heads to check the missing receipts for the system domain, and for the code domain, we cannot. The palette domains have no way to access the palette head receipt info because they are maintained on the palette domain registry. So on the palette domains or on the primary chain, each receipt will be validated to be to point to a valid primary block in the history. And only for the system domain, the receipts, if there are some missing receipts, will be checked for the system domain. The missing receipts for the code domain will be checked on the system domain, which is the domain registry. Yeah, that's the main changes, and also have fix. Not a strict fix. The main purpose of this PR is to resolve a to-do, which is to prune the code domain receipts once the code domain receipts are deep enough on the system domain, and eventually we found out this this storage item block hash to check the pair of primary block number. So the block hash needs to be domain aware. Otherwise, it can have a situation that if one domain stores, if we don't have a domain specific block hash for the corresponding state, will corrupts. Yeah, I think that's all the changes on the code protocol thing. Okay, I think, yeah. And I have another kind of open question. I think I would like to discuss is about the cross domain messaging. We already have a bunch of discussions there, and we think that if we can have a global secondary network, maybe we can have another approach to achieve the cross domain messaging. It was blocked previously because I didn't spend more time to investigate due to some history reasons. But now I have made some changes, and the secondary executor network seems to be fine with these changes. The substantial one is that basically this change. So if we are about to support processing the primary block and thinking from the other the system domain nodes in parallel, the block thinking can be faster than processing the primary block be happen concurrently. So we cannot we can only kind of process the new primary block when this specific primary block is like happen to be the next best block from the local secondary nodes point of view. Otherwise, you can't build a new block without the parent block. They have to be created or built sequentially. I just I'm not 100% sure whether supporting them in parallel will cause some just unknown pitfalls if we will not have, if we are not support them eventually. Maybe such efforts and such issues maybe unnecessary. Just not
To be related to the networking though, like regardless of how network is organized, this asynchrony will be present, right?
looks like so, but supporting both of them just make things a little more complicated. And I'm not sure if there are some unknowing problems maybe. But so far it looks fine. I have run this locally and it looks fine. They can have multiple nodes connect to each other and running. I have run them locally for hundreds of blocks. Okay, it looks fine.
I guess we'll have to run and see what happens.
Yeah.
Eventually we will likely switch
So
to ESN for everything, but it will take a little while.
so we can take this as is, as a temporary solution, so that we can support cross-domain messaging. I think faster, maybe with this fix, we can support the gossip. We can use the switch to the gossip approach for the cross-domain messaging, I think.
Shane, let me make sure I understand what you just said. So we're going to have a separate executor gossip network, and then we're also going to have a separate sync mechanism for the executor nodes. And that's going to, is that right?
Yes, we were just previously, or at this moment, we only have one way to progress in the secondary nodes, which is to process the primary block.
Right.
If we decide
So,
this,
decoupled sync between the primary and the secondary nodes, basically, so secondary nodes can sync independent of primary nodes.
Wait, but why do we need it? Like we didn't need it before, and we don't plan to have compact bundles in the short-term future.
We do, actually.
we can just disable the bundles, but we can have it for the other kind of messaging.
Yeah, that's what I remember. We wanted to use it for gossiping, basically. And we didn't want to hack the transaction pool of the primary node to do so.
Yeah, the cross-domain messaging is the main, I guess, immediate use case, but we do need, this fits into the longer roadmap, which is going to happen incrementally around scalability and compact blocks, compact bundles.
In my opinion, since I don't see obvious problems or issues, I think we may accept this for now and move the cross-domain messaging forward using the gossip based on this global secondary network instead of the primary network. We still need a one global executor network, right?
And you're saying this is a temporary solution because the long-term solution would be to use gossip sub to segment the networks, Chain?
The gossip based on like which networking stack. Currently, this gossip is based on the substrate networking stack. Once we have, we have based on our own like networking stack, we can just switch to our own networking, our own networking gossip. Maybe.
I see. So once the DSN is more robust and extensible, then we can switch that, but we're not there yet.
I think so.
Okay. Roughly, Lu Chang, how much effort do you think is going to be required to get this to the point that we could have a demonstration of the cross-domain messaging?
I think if no new like issues coming out, I think we can have it this week.
Okay. And Nazar and Shamil, what is the rough estimate right now on the DSN being extensible enough that we could have like gossip sub working with like XNet as a topic and like all the different core domains as topics for their subnets?
Further than a few weeks.
Okay.
We are still kind of polishing what we have and optimizing what we have. Yep,
Just to
one of the things
mention, we
I
have
forgot to mention
some
is that
this implementation for Gossip Sub implemented probably four months ago. So we have this protocol enabled.
Okay, so we could use it now. It's just not efficient.
Rather not tested.
Not tested. Okay. Okay. Well, I think we should, as you suggest, Lu Chang, just keep it simple for now, and then we can later upgrade. We can just migrate that, I would assume, from a separate substrate gossip network to a topic within our DSN. Does that make sense to you, Nazar
yeah,
and
it is
Shamil?
still an
You guys
open
agree?
question whether that approach will actually work. I mean, Gossip Sub, as in that article, there are some challenges between different approaches, and whether it will actually work is still an open question. Maybe we'll have to run different completely isolated networks for different purposes, where every participant is interested in that topic. I don't know. We will have to see.
Yeah, no, fair enough. There's definitely some open security questions, at least with Ethereum 2 and Celestius, some of the other layer 1 blockchains interpretation of this. But I think the takeaway was that because our light clients are consensus nodes, the farmers, that we should be able to harden the DHT and make it SOPA resistant much easier than some other protocols. So I think at the end of the day, it's ultimately solvable. It's just that there's still clearly some implementation questions and design questions around that.
A
Okay.
question.
I think we should move forward a little bit. We have just 6 minutes, and we want to give time for the rest to also share their updates.
Yeah, that's my updates. Yeah.
Cool. Ved, do you have anything to share this time?
No, I'm just here to gather what the issues that we fixed last week. Just get some info on that. Nothing from my end.
Okay, but you did work on infrastructure, so that's kind of relevant. But okay.
Okay, I mean, not okay. Cool. Infrastructure, there's a peer out there, but if anyone's interested, I'll be more than happy to have another call if anyone's interested in how we are doing it, and if anyone wants to jump in there as well, let me know. I know that Shamil was interested, so if there is more, I can do another call and get everyone up to speed.
Did we document that this time around, Ved?
Yeah. But it seems like we are always missing one thing after the other. Shamil asked me topology diagram. I don't have that yet. Again, I'm gonna make it in some time, but that's one more missing. If you guys find anything missing, let me know. We'll add more.
Yeah, Vad did write a great document about like all of the steps you need to do start to finish to actually launch the network. We didn't have it before. It was like in my head and someone else's head, like from different pieces you would have to assemble the puzzle, but finally it's like in one place. Okay, yeah. Finally, Daria, curious what you have to share about research.
Sorry. Well, we have been working with Dr. Chen a lot. He's been doing the trying to formally academically describe our consensus and model its security with respect to existing and, well, already proven security models that they have. Basically, the idea is try to reduce what we have to something that's already known, like a proof of stake. And the best discovery he made is that proof of archival storage can actually be more secure than proof of stake. So we're happy about that. I have been also working on applying other ideas found in papers to what we could use. One of them was using similar to Ethereum scheme for that they use for data availability, but for our plotting, which is, it kind of could work, but the proofs are now too huge and it's too slow. So I kind of put it in the drawer. But I wrote a notion about it. And another is another recent idea that I had is so for now to verify if I know correctly, to verify some pieces inclusion into history, we are storing all the record roots, and then we're looking from the storage then to verify whether the piece belongs to record root of a segment. Another idea is that we could, because of KZG homomorphism, we could have a single digest for whole of the history that would commit to those record roots, and that would be updatable with every new segment that is archived. So basically, you could have just the one KZG commitment to the whole history. So there would be like the minimum amount of information you would need to be able to verify that something belongs to the history. However, that applies another, well, basically one more proof to every proof, so like 48 bytes more. But I could explore it in more details this week if we would like to discuss it next time.
Sorry, does that have the same assumptions as other stateless cryptocurrencies where you'd have to update your proofs based on the latest before you could submit the proof? So like the proof of the witness for the piece would have to get updated every time based on that new root?
Yes. And that would depends how much we want to do that and how do we do the audit. So probably we could, one way we could do it instead of updating it. So in stateless cryptocurrencies, they do it every block. Since we're going to be doing every archived segment, is much less frequent. Another approach to that is that you could collect the updates and then apply them all at once when you need to actually submit a proof, instead of like updating it every time that there is an update. Yeah. So there's, space to explore, but I think it could simplify potentially like memory it for something like light client, because this digest will not gonna grow with the history growing. So there's a plus.
Right. Right. So this is kind of the ultimate solution to the farmer's dilemma, where the last piece of state was the root table, and now we're basically compressing the root table down into like one digest, effectively.
Yeah.
Awesome. I'm actually syncing up with Chen later today. We're going to go through a lot of those constructions, Daria. Some of the stuff he's been working on.
Yeah, I'm also having a meeting with him tomorrow. So there's a lot of work
Okay.
this week.
We need to make sure we're in sync on what we're doing with him. I think we're doing it siloed independently. We've got to improve the communication there.
Yeah, I mean, last time when I had a meeting with him, he told me to take notes, and I'm telling you to take notes.
Yeah. Okay.
Awesome. On that note, thanks the whole team for the great work, and thanks everyone for watching on YouTube. And we'll see all of you, I guess, in 2 weeks, actually. We have this once every 2 weeks. Okay, see you. Bye.